So today we would like to do the ELEC207 control theory promotion to lecture 3 and 5. So the first question is to find the transfer function of the feedback system in figure 1. So how the feedback function is defined as follows. Firstly, let's define this is BS times GS, and this is AS plus this is AS plus BS times GS, and together we are going to multiply it by the DS. It's going to be BS. So what we want is the relationship between the AS and the BS. So which means that we are going to multiply them in. So it's AS times DS plus BS GS DS is equals to BS. So we get BS out, which is BS 1 minus GS DS. BS 1 minus GS DS, and on the left hand side is AS DS. Therefore, what we get is BS divided by AS is going to be 1 minus GS DS. So this is the transfer function. Apart from that, the second question is to find the time response of an unit input system with the following transfer function. So what we have is this. Let's see. So HS equals to 5 divided by S plus. So the time response. In order to find time response, we must find the YS first. So how do we find YS? The XS equals to 1 over S, and YS equals to SS times HS, which means HS equals to 1 over S times 5 divided by S plus 3 and S plus 6. So in order to solve that, this is HS equals to S plus, this is all 5 S plus 3 and S plus 6, and actually I'm not sure why I cannot reduce it. It's a bit tricky, doesn't matter. So what is the time response to an unit step input? So the time response, right? The time response. So what we are going to do is using the covering method. So it's if it's going to be SA plus 3B s plus 6c. If we want to s equals to 0, this is a equals to 5 divided by 18. If s equals to minus 3, b is equal to if s equals to minus 3, s equals to 5 divided by minus 3 times minus 3 minus 5 divided minus 3 times 3 is minus 9. And what if s equals to 6? Then this is 5 divided by, they must be 5 divided by minus 6 times minus 6 times minus 3 is 18, so it's 18. So this is the, and after that we just need to transfer it back. For example, this is for example, this is high, yeah, this is 5 over 18 times ut, and minus 5 divided by 9 times e to the power of minus 3t, plus 5 over 18 e to the power of 6t, and all that together we are going to times ut as the outside. So after the P2 problem 1, and we're going to look at P2 problem 2. So P2 problem 2 we have hs as 20 divided by s squared plus 6s plus 144. So hs ys equals to hs times xs, which means that is 20 divided by s squared plus 6s plus 144 times hs means xs means 1 over s. So in this case, what we need is we firstly need to differentiate. We firstly need to differentiate. Yes, what we need is to s squared plus 2s 2 times 3 times s plus 9 plus 135 equals to s. Then what we need is s plus 3 plus 135 20 and times 1 divided by s. So based on this expression, what we can do is 100 and this is 9 plus 135. This is 20. This is s. So this one must be something like s squared plus 6s plus 144 times 1 over s, 20 divided by this. how to do that. I think let's look at how does the professor do that. This is the transfer function, and it's timed with s. Let's go to Vital to see whether we have the solution. No solution yet, so we must rely on our own. 20. How do we solve that? 但是20 s times s plus 3 square plus 135 s. Doesn't matter. The first thing we have already get this one, so which means that oh, I see. So what we are going to do is something like a differential equation, something to partial fraction. Okay, partial fraction is something like I think we are going to I see. So what we finally is going to have is as a and something with s squared plus 6s plus 144. It's something like that. S squared plus 6s plus 144. Plus B, S, and C. The reason why is just that it's kind of an intuition that as long as we have quadratic form on the bottom, we will have one S here on the. What if we do not have the B, S, and C, which is two variable? We are going to ending up as three equations with two unknown variable, which is not good. The reason is that so we are going to we have the coefficient between s squared and the coefficient between the s and the constant. So there are 3 equations, but what if there's only one b or something like that? That is not good. So we must have bs plus c on the numerator here. So that's intuitive, and now we are going to figure out what are the b and c here. So in order to do that, we are going to differentiate s squared plus 6s plus 9 plus 135 and bs plus c, which is going to a divided by s plus 3 squared plus 135 and bs plus c. So now what we have, that's a very interesting part. So the first thing, in order to find out the we need the how do we do that? Basically we do the if x equals to, and this is going to be equal to 20 divided by s times s squared plus 6s plus 144. So what we do here is very simple. If x equals to 0, then a must be if x equals to 0 on the a equals to 20 divided by 144. If s equals to if s equals to how to say, s equals to how to find b here? How to find b? Actually, the thing is that the lecture uses the simultaneous equation. 144a equals to 20. xs times hs is going to have this. The first thing we have a here, and now we have to determine b and c here. So what are the b here? Maybe I will look at, I think the professor may upload the solution. Not yet. Doesn't matter. let's look at B. B doesn't matter. Let's look at this. Let's look at B. B. B is let's look at this question first. It doesn't matter. It doesn't matter. Let's do that. Okay, I can do it. Or I can come to the finish problem 4 first. Okay. So since it is an oscillation with a magnitude that decreases with time, therefore it is an underdamped system. And since it gives you the transfer function, which indicates it is the second order system. So, since it's an underdamped, the z should be greater than 0 and less than 1. So what does that mean? So that means since the generalized form HS equals to s squared plus omega z s plus omega squared. It's therefore omega squared equals to b equals to omega equals to square root of b. That's very intuitive. And since so this is 2 omega z, so it's 2 omega z equals to a. Therefore 2 omega z equals to a. Therefore omega equals to omega equals to square root of b. So 2 times the square root of b times z equals to what? Equals to a. So therefore z equals to a divided by 2 square root of b. So z equals to a divided by 2 square root of b, which implies that a divided by 2 square root of b greater than 0, less than 1. And we can multiply it on both sides, so it's 2. By the way, it is worth noticing that this one must be time. This must be yt, or you will definitely lose mass. So if we want to design a system to be doesn't cause oscillation, how do we choose a as a function of b? That's very simple. So what we need is very simple. So if we want a and b to be non-oscillation, that's simple, huh? So the thing is that we just want z to be greater than 1. What does z greater than 1 mean? Z greater than 1 means z is the same for all variables, which is a divided by 2 times the square root of b. A divided by 2 times square root of b is greater than 1. Therefore, a must be greater than 2 to the 2 square root of b. So a is Yeah, this is the final answer. And another question, it indicates that what if the system and one last thing to be taken into account that if you want to know that there are 2 points, what if it's something like that? That is underdamped, but I mean this is overdamped. What if here is underdamped, and it's a stable system, which means that the magnitude decreases over time. So, so if we want to choose s squared plus as plus b equals to 0, then what do we have? We have s so we have that. So we must have two complex root. Complex root, what does that mean? So 2 complex root means a squared minus 4b, which is less than 0. That's understandable. However, and we must have minus a plus 2 is less than 0. A is less than 0. So what if there's another way to show the first half of the problem, which is a squared greater than 0 less than 4b. So after 4, we are going to look at the problem 3, which is calculating the damping coefficient. So the damping coefficient is calculated as follows. So it's 5 divided by s squared plus 9s plus 18. So 2 omega squared equals to 18. Omega equals to square root of 18. 2j omega s equals to 9s. J equals to 9 divided by 2 times omega, which is square root of 18. So that is the first question. For the second question, let's look at that. So if we want to let's look at that. So if we want this one, so omega squared equals to 144, omega equals to 12, 2j omega equals to 6, j equals to 6 divided by 2 times 12, so it's 1/4. That's also very intuitive. So let's look at this question. So what if it is this? We want the damping coefficient, natural frequency damping coefficient. So this is something we call the s squared plus 20s plus 100. As omega equals to 10, that's very intuitive. And the damping coefficient 2 times omega times j equals to 20. So this is 10 and z equals to 1. Okay. So that is the problem 3, and let's look at problem 2c first. So what we have is HS is this, right? Dun 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 dun. So YS equals to S times S plus 10 square. And what we'll have is something like S1 plus A plus S plus 10 square BS plus C. Right? Right. So if we wanted to do that, that's very simple. What we need is just something BS divided by S plus 10 square plus C. A divided by S plus BS plus C because S plus 10 squared. So that's the thing. How do we solve that? So we can do something like that. I think I have done a wrong thing because I think there are two ways to do that, but I think both are similar. I think this one is better, and the teacher used this one too, because if you times this, you times the S plus 10 on the bottom, you will end up something like this. This is how you determine the coefficient, and that does not matter. So if you wanted to solve that, what you need to do is very simple. You just have to use the cover method. If S equals to 0, then approach to 0, then you just hide S. You find A equals to 100. A equals to 1 divided by 100. And if you cover, you cannot use this because if S approach to 0, S approach to minus 10, S plus 10 to the power of 2 approach to 0 much quicker than S plus 10. Therefore, what you need is to, this is not the thing, and this is S equals minus 10. S equals minus 10 means so C equals minus 10. C equals to minus. Okay, that's cool. And now we have B. In order to get B, we need to solve the simultaneous equation. So what we have is something like S plus 10 square plus 100 times, we are going to S plus 10 square. S plus 10 square. This is going to times 100. And S plus and S plus 10. This is we times 100, and we will have another B here. We times 100. We times 100. We times 100. We times we times 100. We times S, and we times S plus 10. Yeah. And for this one, what we need is we will need minus 10 times S. So this is going to be 0. This is going to equal This is going to equal something very interesting. This is going to be something. S square. By all means, we can solve the a plus b equals to 0, and on the left hand side, which is just the original equation, and then we can solve the b. Yeah. For this problem, what we need is to put the transfer function into a form like that. And then we are going to divide them into two parts, and use the cosines Laplace transform with unshifted in frequency by 3 with a shift of 3 units in the frequency in the S domain. Then we will end up with this final. Thank you very much for the subscription.